Welcome to another episode of NASA Science Live, an opportunity for you to interact with NASA experts and have your questions answered in real time. I'm your host, Megan Cruz, and today we will talk about some of the extreme weather conditions we've been seeing across North America. In fact, just hours ago, NASA announced that July 2023 was the hottest month ever recorded on Earth. It was also the hottest July on record, according to NASA's global temperature analysis. If you have questions throughout today's show, you can send them in using the hashtag AskNASA on social media or drop them into the comments section wherever you're watching us today. Now, joining me now are two climate experts to discuss this record-breaking news and explain what we can do moving forward. Dr. Kate Calvin, NASA's Chief Scientist and Senior Climate Advisor, and Dr. Gavin Schmidt, Director of NASA's Goddard Institute for Space Studies. Thank you both for being here.
Thank you for having us.
Thank you.
So again, today NASA announced that July 2023 was the hottest month ever recorded on Earth. We know this and can say this with confidence because of NASA's global temperature record. Gavin, can you explain what this record is and what this July looks like in the context of that bigger picture?
Absolutely. So NASA gathers information from weather stations around the globe, from ocean buoys, from ship records, from automatic weather stations, and it kind of knits it together to produce an estimate of the global mean changes over time. And we can do that accurately going back to roughly the mid-19th century. And what we've seen in recent years is ongoing global warming. But what we've seen specifically this month is that this July was so much warmer than all previous Julys. And because July itself is in fact one of the warmest months of the year globally, that means that it was the absolutely warmest month in that whole record, going back at least to the mid-19th century. One of the things that we also do is we can compare that to other estimates of what's going on through what are called reanalyses, which is the weather forecast models, or directly from satellite instruments. And all of those sources of information confirm that July was record anomalously warm across vast swaths of the globe.
Yeah, and that graphic we really saw this July spike in comparison to all the other average changes we've seen in the record. How much more is this July that change than other changes we've seen prior?
So the margin by which the record was broken was over 0.2 Celsius, which is almost half a degree Fahrenheit, and the uncertainty in one of those numbers is just like 0.08. So the difference between 2023 and 2019, which was the previous record, was hugely significant.
Yeah, big difference there. So we know we have the hottest month on record. Kate, how is the rising global average temperature and the climate change manifesting in these different kinds of weather, extreme weather we've been seeing across North America?
Yeah, thanks, Megan. So climate change is more than just changes in temperature. There's other changes that we see in the Earth system, things like increases in sea level, declines in Arctic sea ice. We see changes in the water cycle, so you get more heavy precipitation events, heavy rainfalls, and in some regions, more droughts. We also see more extreme events like heat waves or wildfire. For something like a wildfire, climate change can affect both the fuel for fire, so it can dry out vegetation so that there's more that can burn. It can also produce fire weather, so conditions where it's hot, dry, and windy, and they're very conducive to fire. And climate change drives all of those. And at NASA, part of what we do is observe what's happening in different parts of the Earth system, both now and as it changes over time, so that we can study those effects and how they're changing. So for something like sea level, we have one satellite or a series of satellites that have been able to show us total sea level, so we can see how much sea level has risen all around the world. But we have other satellites that'll show us some of the contributing factors to that. So we have another set of satellites that have been able to show us changes in the mass of ice sheets. So as ice sheets melt, that water runs off into the ocean and contributes to sea level rise. And we're able to see those effects of climate change and how they're changing over time.
So we have a lot of opportunities to track the effects, but then what are the causes and how has NASA identified those causes?
Right. So NASA is keeping track of the causes of climate change too, whether that's changes in greenhouse gas concentrations, changes in the activity of the sun, changes in the stratosphere because of volcanic effects, changes in the natural system, whether there's an El Nino or a La Nina. NASA is looking at all of those different elements as well. Atmospheric pollution, deforestation, all of that comes from NASA data, and then we can integrate that information using climate models, using statistical models to try and piece together what the fingerprints are of any of those different changes, and then fit those fingerprints to the evidence that we have. And when we do that, what we find is that the long-term trends that we're seeing, that you saw in that earlier graph, are all due to human activity. Dominant in that is the role of greenhouse gases, carbon dioxide, methane, CFCs, and there's little roles for all of those other things as well. But the main result from that analysis is that those trends that we're seeing, that are pushing us ever warmer, are really just a function of our increases in greenhouse gas emissions.
So, in being able to pinpoint, this major contributor, why we're seeing what we're seeing, what is NASA doing to help communities tackle climate change when you do know the majority cause?
Yeah, thank you. So one of the things that we do at NASA is that we're observing the Earth. So we're seeing these changes, we're seeing what the Earth looks like now, as well as how it's changed over time. And we provide all that information publicly so that people can use that in their decision making and in their understanding of what's happening in their communities. So just like a few examples of things that we've provided. One, when we're talking about greenhouse gases, we have an instrument on the International Space Station called EMIT. EMIT was designed to study mineral dust, which can reflect or absorb sunlight, but it also can identify methane superemitters. And so we're putting that information out publicly so people, know where those methane plumes are coming from and can use that. We also have another tool called OpenET that's helping farmers better plan their irrigation. So it can tell how much water is coming off of their crops out of the soils and better plan when to put irrigation back in, and so that their crops will produce better crops going forward. And so we do all that information and make that all publicly available. We're also developing technologies that can help people respond to climate change. So everything from sustainable aviation to we do research in growing crops. Some of that's done on the International Space Station, but has benefits right here on Earth.
Yeah, I think it's great that we make that data publicly available so that people can change their actions if there's something that they can do to help curb what we're seeing. So we have a lot of questions already coming in from viewers watching online. Remember, you can submit questions using hashtag AskNASA or posting them in the comments wherever you're watching us today. So if you're ready, guys, the first question is from Emil on Instagram and asks, will these records keep being broken, or is there a maximum of heat possible in global temperature?
Yeah. So the bad news is that these records will continue to be broken. We will expect record-breaking August temperatures as well, given the ongoing incipient El Nino event in the tropical Pacific. We expect that records for the rest of 2023 will start to break records too. 2023 might not quite be the warmest year on record, but it'll be very close. And 2024 will very likely be the warmest year on record. That's in the short term. In the longer term, we're going to continue breaking these records as long as we continue to emit greenhouse gases. Perhaps not every year because of the the ups and downs of natural variability. But what we will see is that every few years we will be getting new record temperatures being set. Now, is there an absolute maximum? That's a little bit hard to say. I think if you look at the other planets in the solar system, particularly Venus, it might be that maximum temperature is extremely uncomfortable for humanity and indeed all life. So unfortunately, there's no global thermostat that is going to suddenly come and make this all go away. Sorry.
Yeah, and just to add to that, so there is a science community that looks a lot at projecting climate change into the future, and Gavin and I have both done a lot of work in that. And really, what you find from all of that work is that future warming depends on future emissions. And so they can look at how much warmer it'll get in the future, but there's a lot of options there because it depends on how much we emit between now and that point in the future.
Thank you both for those answers. The next question comes from at the side of the sun on X and asks, why not just release actual temperatures rather than temp anomaly on the y-axis?
That's a great question. So what is it that we're doing here? We're putting together an estimate of the global mean. Now, that there's no one measurement that is the global mean temperature. You can't get that from space. You can't get that from a single station. And so when you want to look at what's happening at the globe altogether, you have to put together a lot of different raw data. So you can go and download the raw data that goes into these calculations. In fact, you can download all the code and you can just do the calculation yourself. And feel free to scoop us next month. But we're using the raw data and then we're just kind of stitching it together statistically to get a best estimate of what the global mean change is. And it's important to know what the uncertainties are in these things. So for the annual mean, it's around 5/100ths of a degree for the annual. For a monthly mean like this, it's about 8/100ths of a degree uncertainty because of that stitching process. And you can check whether different methods give you a different answer, and unfortunately they don't. So whether you look at the weather models, whether you look at the satellite data or the atmospheric temperature data or other people's methodologies, all of those things are lined up and are saying that July 2023 was record-breakingly warm.
John Weigel on Instagram asks, how are scientists able to estimate climates thousands of years ago?
Oh, well, I might as well take that as well. So the instrumental record, as you can see in that graph, went back to roughly the mid-19th century. Our information about climates beyond that rely on what are called proxy records. So these are things like ice cores or tree rings or cave records or ocean sediments where there's some geophysical or biological factor that responds to the climate. For instance, we can see where the ice sheets used to be 20,000 years ago because they've left literal scars in the landscape that we can date, that we can assess. And so there's been a community of folks working on that kind of question for about the last 50 years. And so our estimates of what happened during the Holocene, what happened during the last ice ages, when it was last as warm as we think it might be back in the Pliocene or the Miocene or in the Cretaceous. All of those things are built from big networks of proxy data that have been put together relatively well, and we don't have the accuracy for those past data that we have for July during the modern period, but it does give you a sense of where we are with respect to that kind of context of change.
Mm-hmm. Kate, why don't you take this next one from Brianna Rodriguez on Instagram? She wrote, what are the 3 biggest causes of climate change? We talked about the first one, but she's interested to see other causes.
Yeah, so if you think about how warm it is on a planet, any planet, whether it's Earth or not, you've got an amount of sunlight that's coming in, and that has to do with how close you are to your star, the angle of the surface. Then you have some of that that's reflected back into space based on the color of the surface, and some of that that's absorbed or trapped. So greenhouse gases will trap heat. So on Earth, greenhouse gases, and namely carbon dioxide, methane, and some other gases are trapping heat. So when we have sunlight coming in, we're trapping a lot of that. There is some that's reflected back into space, and the color of the Earth's surface affects that. So darker colors absorb more heat, lighter colors reflect it. We also have things like the oceans will absorb some of the carbon. So when we burn fossil fuels on the Earth's surface, some of that goes into the atmosphere and is trapping heat. Some of it is absorbed by land and by ocean. If you look at numbers, So human activities are what's causing climate change on Earth now. So we can attribute the climate change we're experiencing. Greenhouse gases in particular actually lead to more warming than the total warming we experience, because other aspects of human activities like sulfur will reflect that and lead to a cooling effect. So I'd say if you're looking for the simple, human activities, principally greenhouse gases, are warming the planet, is probably the most straightforward way to say that.
I think maybe if I just add very briefly. So in terms of the individual gases, the dominant thing is carbon dioxide, followed by methane, followed by chlorofluorocarbons, CFCs, and then ozone. And that's slightly balanced by sulfate emissions, nitrate emissions, and deforestation. But the two biggest things are carbon dioxide and methane.
A few viewers are wondering about today's temperature announcement and if there are connections between this and the Tonga volcano eruption in the South Pacific last year. Could you explain?
Sure. So one of the things that NASA does is that we look at all sorts of aspects of the Earth system, and one of the instruments on a satellite called Aura is the microwave limb sounder, and that is able to give us pictures of how much water vapor there is in the atmosphere, going all the way up from the tropopause to the mesopause. So very high up in the atmosphere indeed. And what that's shown is that the Hunga Tonga eruption added about 10%